Good morning, one and all. In today's lecture, we will solve the numerical on the torsion. Last lecture, we have seen the definition of the torsion as well as I have explained torsion formula. You know the torsion formula T by J is equal to G theta by N is equal to tau by R. Okay. In today's lecture, we will solve two different numericals. First, see, in the first numerical, you have given a solid circular shaft in the power is equal to 100 kilowatt. Okay, this power is given 100 kilowatt. I have converted into watt. How to convert? Kilo means 10 raised to 3. 100 into 10 raised to 3 watt. Okay, and you have given when the turning at 26 revolution per second, means you have given the RPS value, revolution per second. How to convert into the minute? Okay, per minute, then you have to multiply by 60. You have to multiply by 60. Then speed is given, n is equal to 26 revolution per second is equal to 26 into, how to convert into revolution per minute into 60. Okay, then you will get the 1560 RPM. And at that time, the maximum stress induced is given, shear stress is induced, tau is equal to 100 MPa. Then we want to find out the required, or we can say the suitable diameter. This type of question will ask for the 6 mark. Okay, all of you getting? One solid circular shaft is given. The power is required. They have given 100 kilowatt. The speed is given 26 revolution per second. Tau is given 100 MPa, and we want to find out the diameter. Then how to find out the diameter? See, what we want to calculate first. Remember that we know the general formula for the torsion. T by J is equal to G theta by L is equal to tau by R. Check that which value is given in the first numerical. T, we don't know the T, we don't know the J. Again, J theta and L, this value we don't know. Tau is given. That's why you have to use this relation. You have to use this relation. We don't know the G theta and L value, but we can calculate what we want to calculate. Diameter. It is related to the radius. It is related to the radius. Okay. J you can calculate. It is related to the again diameter. Then torque is related to the power. Okay. And tau is given. That's why you have to use this relation. T by J is equal to tau by R. T by J is equal to tau by R. All of you getting? First see, think reverse direction. Okay. Then calculate the value. What is the J? J is the Planck moment of inertia. How to calculate that J for the solid shaft? This is very important. For solid shaft, we have seen in the last lecture what is the formula. J is equal to what? J is equal to 5 by 32 into d raised to 4 is there. D raised to 4 is there. How to calculate the R for the solid shaft? R is equal to, can I write D by 2, diameter divided by 2, you will get the radius of that solid circular shaft. Okay, you know this 2 value and tau is known. Then easily you can calculate the, we want to calculate the value of T. Then how to calculate the value of T? Power is given. What is the formula of power? T is equal to, I will write 2 pi n T divided by 60. Okay, constant as it is 2 pi into n is equal to revolution per minute. Converting to revolution per minute. 26 into 16 is 1560 into T as it is. We don't know. Then you will get the T. T is equal to, if you have calculated, then you will get the T is equal to 1612.13. This you will get in Newton meter. You will get in Newton meter. Okay. Then see, next we want to the calculate diameter. Okay, this diameter again, check that we want to the calculate in the mm. Then how to calculate that diameter in mm? How to get this P is equal to, because power is given, check that 100 into 10 raised to 3 is there. 100 into 10 raised to 3 is there. Power is equal to, you will get the T is equal to 612.13 Newton meter. How to convert it to mm? Suppose we want to convert it to mm, then multiply by what? Yes, correct. 10 raised to 3 is there. Newton mm. Then put this value in the equation. This equation, we know that T is equal to what? 612.13 into 10 raised to 3 is there. Newton mm. J is equal to what is the J? 5/32 into d raised to 4. Because you will get the value in mm. This is mm raised to 4, right? And this is Newton mm. Then tau, why I have converted into Newton mm? Yes, anybody tell me? Can I put this as it is value? No, because see the value of the tau. Tau is equal to 100 MPa. What is the MPa? Newton per mm square. MPa means what? Newton per mm square. That's why I have converted this T value into again Newton mm. Then check that tau is equal to 100 Newton per mm square. Okay, divided by R. R is equal to again d by 2 is there. D by 2 is there. If you have calculate this, then you will get the value in d cube. Then take the cube root of this. You will get the d is equal to 31.47 mm. If you have taken the cube root, then you will get this answer. Okay. This type of numerical you will ask for the 6 mark. Here is a conversion is very important. Then what is the given data? Think about that data. Okay, and you know how to use the formulae. Yes, all of you getting? Yes, good. Then second one, see in the second numerical you have given the hollow circular shaft is given having the external diameter. I have shown here one hollow circular shaft having the external diameter is a 120 mm and internal diameter is given 100 mm. Okay, then there is a maximum shear stress induced. You have given the 95 MPa or Newton per mm square, and maximum twist. Okay, means you have given the theta is given. Maximum twist means theta max value is given 3.6 degree. Then how to convert the degree into radian? Because we want the theta into the radian. Then you have to multiply by pi by 180. Then length of that hollow circular shaft is given 3 meter. I have converted into the 3000 mm. Okay, and one relation is given. This maximum torque is more than 30% of the average torque. 30% of the average torque. Then you will get the relation indirectly. T max is equal to 1.3 T minimum. 1.3 T mean torque. Okay, this relation is given, and you have given the motor speed of that shaft is given 2 rps revolution per second. How to convert again into revolution per minute? 120 revolution per minute. Okay, multiply by 60, and modulus of rigidity is given 80 GPa. 80 into 10 raised to 3, you will get the MPa. And what we want to find out? We want to find out or calculate the shape power. We want to calculate the shape power. How to calculate that shape power? We know the power formula. Again, see, one side I will write all the formulae. What will require? First, what we want to calculate? Check that. What we want to calculate? P shape. what is the formula of power? P is equal to 2 pi n t. T, which t is here? T mean. Yesterday's lecture we have seen which t? T mean divided by 60. Okay, divided by 60. We don't know the value of t, we want to calculate. But how to calculate the t mean? How to calculate the t mean? Mean again in this problem or numerical, n is known, only the unknown is t minimum. T mean is there. See, one relation is given, t max is equal to 1.3 t mean. T max is equal to 1.3 t mean. But we don't know the t max again here. We don't know the second step, t max, right? Then how to calculate the t max? Here is a two conditions are given. Okay, here is a two conditions are given. First is given when the tau max is maximum, that time we want to find out the value of torque. Again, if the theta max is given maximum, then we want to find out the torque again. That two conditions are given. Check that two conditions. Okay, to find out the maximum torque. This torque based on the shear test. Okay, torque based on the maximum shear stress and torque based on the angle of twist, maximum angle of twist. Okay, that two conditions are given. We want to find out the both torque and find out the least value of the torque. Means what is the step number 3? 3 is you have to calculate the t max value. Then how to calculate that t max again? Here is a both condition is given. First is a tau max is equal to, check that how to calculate that t based on torque based on maximum shear stress. Okay, this is the first condition. Torque based on the maximum shear stress, you will get the first torque. And same torque based on the what? Torque based on the what? Theta max. Theta max. Here you will get the both value of the torque, t max value. Then you have to choose the least value. Least value. This is the step number 3. This is the step number 3. Okay. Here you will get the t max value. T max value. But how to calculate the again how to calculate the again? Here check that these two conditions we are taken. T by j is equal to g theta by l for the first, and second t by j is equal to tau by r is there. Then again which formula will require? We want to calculate the j value. Okay, because here is a which shaft is given? Hollow circular shaft is given. You know for the hollow circular shaft, what is the value of j? J is equal to pi by 32 into d raised to 4 minus small d raised to 4. Small d raised to 4. In this way, you have to go through the reverse direction. First, what we want to calculate P. Unknown is T mean. Then how to calculate? They have given the relation T max is equal to 1.3 T minimum. How to calculate the T max? You have given the two conditions, torque based on the maximum shear stress and torque based on the maximum twisting moment. Okay, you have to choose the least value, and after that first we want to calculate j value. Because t by j is equal to tau by r. Yes, again in this formula t by j is equal to g theta by l. We require that j value. That's why we want to calculate the j value. Other values are given. Check that. Okay, can we start then? And we'll start. First we'll calculate which value. Yes, anybody? Good. Polar moment of inertia. J is equal to pi by 32 into d raised to 4 minus 1 d raised to 4. Okay. What is the value of j? Pi by 32. What is the d raised to 4? Capital D. 120 is given. 120 raised to 4 minus 100 raised to 4. You will get the j is equal to, check that. You will get the j is equal to 10.54 into 10 raised to 6. What is the unit? Yes, mm raised to 4. J is equal to 10.54 into 10 raised to 6 mm raised to 4. Then second, what we want to calculate? We want to calculate the maximum torque. How to calculate maximum torque? First condition, torque based on maximum shear stress. Torque based on the maximum shear stress. What is the formula? T by J is equal to tau by R. Okay, we want to calculate the T. T as it is. What is the J? 10.54 into 10 raised to 6 is equal to, what is the tau? Tau is given Tmax 95 LPa. It's 95 as it is. Okay, divided by R. R is equal to D by 2. Then which D is choose? Internal or external? You have to choose the maximum value of D. 120 divided by 2 is there. R means what? 120 divided by 2 is there. Then I will check the value of that. Check the value of that. T is equal to 16.68 into 10 raised to 6. What is the unit of that? Newton mm. Newton mm. Because we have taken one value in mm. Then second condition, what is the second condition? Torque based on what? Torque based on angle of twist, means theta max, maximum angle of twist, theta max. Then again you have to choose the second relation. T by J is equal to G theta by L is there. T as it is, we don't know. Don't put this value in that equation. We want to calculate the least value. We want to calculate the least value. J is equal to again 10.54 into 10 raised to 6. Okay, 10 raised to 6 is there. Then is equal to G. What is the value of G? 80 into 10 raised to 3. 80 into 10 raised to 3. What is the value of theta? Check that. We have converted to the radian. 3.6 into what? Pi by 180. Pi by 180 divided by what is the length of the shaft is given? 3 meter, means 3000 mm. 3000 mm. Then what is the value of that T? T is equal to 17.65 into 10 raised to 6 Newton mm. Then guys, tell me the which value is the least value, this one or this one? This value, from the both condition, check which is the least value. This first one is the least value. You have to use this value. We know the relation. Yes. Which relation? All of you getting? Yes, very good. Then next relation, T max is equal to what? T max is equal to 1.3 T min. Okay. Then what is the value of T max? T max is the least value, 16.68 into 10 raised to 6 is equal to 1.3 T min. Okay. Then if you calculate the value of T min, then you get the 12.84 into 10 raised to 6. Then what is the unit of this? Newton mm. And how to convert into the meter? Then you have to convert into the meter. 12.84 into 10 raised to 3 Newton meter. Okay, Newton meter. Okay, now got the value of T min. Then final stage, what we want to calculate? We want to calculate the shape power. Okay, how to calculate the shape power? P shape is equal to 2 pi nt min divided by 60. When you calculate the power, then check that what is the unit of power, kilowatt or watt, kilowatt or watt. Okay, you have to check this. We require this value. T value is a Newton meter. Newton meter. Then put the value 2 pi n. What is the value of n? Speed is given. Speed is given. What is the value of speed? 120 rpm. And what is the value of t mean? 12.84 into 10 raised to 3 divided by 60. Divided by 60. Then you will get P safe value. What is the safe value of the power? 9681.13 kilowatt. Okay, this is your answer. Okay, very simple. You have to use only one formula. T by J is equal to G theta by L is equal to tau by R. If you have given the both conditions, okay, tau max or theta max, then you have to use the different two conditions and find out the least value of the torque, least value of the torque, and use this value to find out the power value. Power value. Here is a conversion is very important. You know the knowledge of the units. Units are very important. Okay. Okay. Today we will stop here. Next lecture again we will see some numerical on the given different conditions. Today we will stop. Thank you.